Hey, welcome to example number 6. This is a question regarding, it's an old IB exam question actually, and a student makes the following statement. If you have a kettle that you bought in the UK that is made to operate at 240 volts, the student reflects upon this and says, this means that if I were to take that kettle that I just purchased that was manufactured in the UK and I brought it to the United States, then it'll take 5 times longer, roughly, to boil water than it would in UK if I were to just simply connect this kettle to a 110 volt power supply. And so what you're asked to do is show that the student is justified in making this statement. Basically, that is a correct statement. And you need to state what assumptions that you've made. So what assumptions do we have about this kettle? What are the key things that remain constant, that don't change from one place to the other when you move from the US to the UK and vice versa? You've got this kettle, it's manufactured in the UK, but there's something that doesn't change when you bring it over to the United States. It's really the same kettle, isn't it? So it means this heating element that's heating up this water is not changing, because the length of this wire inside here and the cross-sectional area and the resistivity of that metal is not really changing. Remember, resistance equals rho L over A, and these are all constant. So the first assumption we would make is that the resistance of kettle, or the metallic element, heating element in the kettle, remains constant. Second assumption. I guess we'll have to assume that when you fill up your kettle to this mark right here, that you're going to fill it up to exactly the same level. So we're going to assume that the same amount of water is boiled. And so if the same amount of water is boiled, that means, if we reflect upon that, then it must be the same amount of energy. I'm assuming that you're using the same water. It's not going to be different water in the US that much from UK. So it's the same energy used to heat the water. So we have the same energy and we have the same resistance. But what is different is the current that is going to be flowing through the wire, because we're going to have one that is at 240 volts and one that is 110 volts. And remember that voltage equals current times resistance, and so the voltages are different, the resistance are the same, so the current must be different because the voltage is different. Secondly, the power will be different as well. The rate that you heat the water in the US will be different than the rate that you heat the water in the UK. So let's start off with this assumption that the energies are the same. The work done in the US would have to be equal to the work done in the UK. And we know that work equals power multiplied by time. So the power in the US multiplied by the time in the US must be equal to the power in the UK times the time in the UK. Now, both powers will be different, both times will be different. We're hoping to show that the time in the US will be roughly 5 times the time in the UK. So we could rewrite this as time in the US equals the power of the UK divided by the power in the US multiplied by time in the UK. So now we need to replace the power. So let's bring in that voltage. We don't know the current, so I think it's better if we use the voltage and the resistance, because the resistance is constant. So hopefully you recall there is a formula that relates power and voltage and resistance, and that's power equals voltage squared divided by resistance. So now we replace that in for each the UK and the US. we have the voltage in the UK squared divided by the resistance divided by the voltage in the US squared divided by the resistance multiplied by the time in the UK. And you'll see that the resistance cancels out because we're assuming it's the same kettle with the same heating element. So now we have the following equation: voltage in the UK squared divided by voltage in the US squared times the time in the UK. And now we can substitute in our voltages. The voltage in the UK is 240 volts, and the voltage in the US is 110 volts. Each of these are squared. And you're going to get 4.76 when you square these two numbers times the time in the UK. So the time in the US is roughly 5 times the time in the UK. And the student is correct in making that justified statement. That's it.